This video for sig figures, I'm gonna talk about all the sig figure rules along with the computation of sig figures. Okay, it's like multiplication, addition, division, things like that. Okay, let's talk about that. So sig figures, significant figures, sig figs rules. Okay, so first rule you need to know is all non-zero numbers are sig figures. So all non-zero numbers are sig figures. Okay, so example. Let's say you have a 33.2 and then how many sig figures? There's a no zeros, all the numbers non-zero, so you have a 3 sig figure. Okay, rule number 2. Zeros between two non-zero digits are significant figures. So zeros between two non-zero digits are significant. Okay, so example. You have a 2051. Then this zero count as a sig figures because it's between two non-zero numbers, right? So you have this one 4 sig figure. Rule number 3. Leading zeros are not significant. Are not significant. Okay, so example. Let's say you have a 0.0032, then only these two is a sig figure. Okay, leading zeros is not significant. So 2 sig figure. Rule number 4. Tailing zeros to the right of decimal, to the right side, right of the decimal are significant. So example, let's say you have a 92.00. Okay, so those two zeros is count as a sig figures. Okay, so you have a total 4 sig figures. Number 5. So tailing zeros in a whole number. What is a whole number? Like 0, 1, 2, 3, those are whole number with the decimal shown. Okay, with the decimal shown are significant numbers. So they are significant. Okay, with the decimal. Now, so example. So 540 dot, and then you see that there is a decimal shown, then all of them, they are sig figures. So you have 3 sig figures. Okay. Rule number 6. Trailing zeros in a whole number with no decimal shown, with no decimal shown are not significant. Are not significant. Okay, so example. So the same number 540, but there's no decimal. Then this one doesn't count as a significant figure. So you have 2 sig figures there. Okay. Now 7, exact numbers. Exact numbers have an infinite number of sig figures. So example, let's say you have a 1 meter, then that's a 1 sig figure. And you can say same thing, but 1.0 meter, you can say that's a 2 sig figure. You can add as much as you want, 1.0000 meter. Then you have a 5 sig figures. So as you see, you can, for the exact number, you can add a infinite number, right? So infinite number of sig figures you can add. Okay. Now, rule number 8. For a number in scientific notation, for a number in scientific notation, what is the scientific notation? You have to have only 1 digit before the decimal, right? And 10 to the like x, like that. You have to have only 1 non-zero digit. That's what we call scientific notation. So this whole thing, right? So that one is all digits composing, let's say this one n, right? Then they are all sig figures. Okay, so example. So you have a 1.10 times 10 to the third. Okay, how many sig figures there? So this is nothing to do with the sig figures, so only these 3. So 3 sig figures. Okay, that's how you're gonna count the sig figures in scientific notation. Now let's talk about other rules. So rules for mathematical operations. Mathematical operations. Okay, so like addition, subtraction, multiplication, division. How you gonna do that? So number 1, plus minus operations. They have the same rules. Okay, so then this one, the result is round off. The result is rounded off to the last common digit. Okay, very important, last common digit occurring furthest to the right. In all components. Okay, so example. You add 100 plus 23.643. So how you gonna add this one and how you gonna write as a sig figure, correct sig figures? So decimal, even if we don't have any decimal, so that means a decimal is hidden there. So when you add, this one is 123.643. But when you add, it said the last common digit. Okay, last common digit is, you don't have any digit after decimal. So unit digit is, or you can say ones digit or unit digit is the digit you need to round up. So you need to round up to here. So you look at the next one. Next one is a greater than 5. So you add 1 to 3, right? So then answer is 124. Okay, that's how I'm gonna answer. So you have a 3 sig figures. Now, rule number 2. What about multiplication and division operations? Right? Then the result is rounded of so as to have the same number of sig figures as in the component with the least number of sig figures. That's very important. With the least number of sig figures. Okay, so this keyword. So when you multiply or divide, you follow the same sig figures with the least number of sig figures when you multiply or divide. So example, 3.0 times 12.60. So you have here 2 sig figures, this one 4 sig figures. So you have to follow 2 sig figures in your answer. Now when you multiply, so don't round up during the multiplication. So you just multiply as it is, so which is 37.8000. Now 2 sig figures, so you have to round up to here. Then you look at the next number, is greater than 5, so you add 1 to 7. So answer is a 38. Okay, so that's the 2 sig figures. Okay, that's how you're gonna add or subtract or multiply and divide. Now let's talk about the last rule. I want to talk about the rules for rounding of numbers. Okay, general rules for rounding of numbers. Okay, so first one, number one rules, and if the digit to be dropped, if the digit to be dropped is greater than 5, the last remaining digit is increased by 1. Is increased by 1. So example, 12.6. Now when you round up to the nearest unit digit, then you look at here, that's greater than 5, then just 13. The 2 sig figure, but it's round to the 13. Number 2, second rule, if the digit to be dropped is less than 5, the last remaining digit is left as it is. So example, let's say 12.4. So you round up to the nearest unit digit, and this one is less than 5, so you just drop. So answer is 12. Okay, that's how you're gonna do. Now next rule, number 3. What if, so if the digit to be dropped is 5, okay, it's not greater or less than, is 5, and if any digit following it is not 0, okay, then the last digit last remaining digit. Remaining digit is increased by 1. Okay, so example. You have 12.51. Okay, so when you round to the nearest unit digit, so this one is exactly 5, and the next one following it is not 0, so you just add 1. So answer is 13 into 2 sig figure. Okay, number 4. Now also, if the digit to be dropped is also 5, and is followed only by zeros. Only by zeros. Then the last remaining digit increase by 1. If it is odd, okay, the last remaining digit is odd, then increase by 1. But left as it is, if it is even. Okay, so let's make an example. So I'm going to give you 2 examples. Let's say 11.5. Okay, and as you see, the digit to be dropped is this one, 5, and then it is followed by nothing. Nothing means zeros. Okay, so it's followed by only zeros, and the last remaining digit right here, that is odd, right? Then increase by 1. So answer is this one is 12. Okay, into the 2 sig figure. What about 12.5? Now also, the last digit to be dropped is a 5, and then it followed by all zeros, right? Only zeros. Then look at the last remaining digit is even, then it left as it is. So answer this one also 12, not 13. Okay, that's a little tricky. Okay, that's very important. Okay, so I think that's it for these rules, and then I'm gonna make another video for your practice worksheet. Okay, so this one just take a note, and then also you can use as a reference.